Hi, welcome to Team Woolly Sheep Reviews. Show you this later. So, I hope you're getting ready for Christmas, because I have a few ideas. Not much flying going on for me, I'm afraid. Lately the weather's just been awful. Through the week, been great. Working from home, looking out the window, said this weekend, get some flying in. Absolutely gutting, given the weekend. What happens? Last time I flew, or one of the last times I flew this. Now somebody might recognise this as a Harrier S1100. I flew it. It was way underpowered and one of the motors had coughing and spluttering. So they were nice little carbon fibre pads, but they were glued on. So I ripped them off and put the 3D printed ones on. Another problem I had was visibility. It's grey, it's silhouetted in the sky. Didn't have a clue what was going on. It looked really nice, but I couldn't tell top to bottom. It needed a bit of a facelift, so I give it a facelift. So I should be able to see that in the sky now. It's and to be honest, I'm really pleased with that. That looks awesome. I noticed the only vertical stabilization was the wingtips. So I designed and printed my own little vertical stabilization add-ons. It's very thin, 1mm in 3D printed and branded with ASBO. What I did, I've used the actual joining, the wing joiner track, glued them in. A little bit of U-hoop paw, works perfect. My 3D printed covers. The reason I haven't stuck the covers back on, I wanted to show you these. I needed some, these are 30 amp speed controllers, so I went out and I bought some motors. And this is the purpose of the video. I wanted to talk about what I did to select these specific motors. The bigger the motor, the more nose weight you need. So I thought I'd sort of try and get something that's more efficient. And I come across these Emax ones. They're the XA2212s, and these are spinning at 1400 kV. What I did, I bought these 30 amp speed controllers from Aerostar, from our friends at Hobby King, and they're metal cased. So I thought they'd be ideal, sat in there with a bit of ventilation. They got a nice aluminium case, and so heat is not going to be a problem. Right, so how did I get to this situation? Weight to the plane. Load up the plane, put the batteries in, let's get an idea of what the weight of the plane is. Then we can work out what sort of thrust we need from this pair of motors. Power to weight. How do you know what motor? How do you know what speed controller? You've got no clue, you've got no instructions, and you're trying to figure out what's the best motor. Power to weight. I need to match a motor to the weight. How am I going to do that? In the words of Joshua Bardwell, you're going to learn something today. So if I load it up with the 2200 3S batteries, and that's giving me the center of gravity I need. A kitchen scales, and weigh it. Just a normal kitchen scales. Put it on the bench, and we'll weigh it. That's coming in just over 1.4 kilograms. Just over 1.4, say 1.5 kilograms. So you're looking for a pair of motors to deliver you anything above 1.5 kilograms. First of all, I need to know the length of the props, the maximum length of the props, because it's a twin motor setup. Then you don't want the props hitting each other. So as you can see, I've got 2 inches gap in there, so I've settled on an 8-inch prop to suit these motors. I think it's an 8x6 prop. So that on paper should give me enough thrust. Those that worked out, it was about 900 grams of thrust per motor on an 8x6 running on 3S batteries. So that should be more than enough to fly this plane. The acid test is plug a battery in and see what sort of thrust you got. And then simply spin it up and see if it can hold its own body weight. That was holding its own body weight at half throttle. At full throttle it was lifting, and that should be more than enough thrust to fly this plane. Obviously when it's going horizontal, it doesn't need so much thrust. But obviously to get it off the ground, what I've always found is if it can hold its own weight at about half throttle, then the extra throttle is a bonus. And this with twin motors sounds absolutely amazing. But what you need, if you haven't got one, get one, is what we call as a watt meter. It's a precision watt meter and power analyzer. It is nothing complex or worrying. It is quite simply, you plug the battery in there and you plug the model in there and put it in series with the battery. And then what you do, you give it the full throttle. When you give it full throttle, this will tell you how many watts and amps, etc. that is taken from it. If you hold it full throttle and then stop, it will tell you, it'll scroll through, it keeps a little log, so you can see in this bottom corner the scrolling readings from the highest, from the peak power. It's a great tool to check that you haven't over propped it. If you put too big a prop in it, the motors will get hot and you'll probably burn the speed controllers out and you'll end up crashing and breaking the model. So always check you are not exceeding the capacity of your speed controllers. So I've got two 30 amp speed controllers, so I've got to make sure that I'm not drawing more than 60 amps on full throttle. If I am, then I'm in the danger zone. No, I'm not cueing the music. I'm going to run it full throttle and then we'll see what the readings are. And that's all you need to do. A couple of seconds, full blast. And what I can do, just to make life a little bit easier, I'll unplug the model and bring the battery in. You can see this figure here is scrolling through the amps and the power. That this was taking 35 amps, 351 watts. So if I look at the spec of the motor, why doesn't it tell the power of the motor on there? You have to go on the website and have a look. Bear in mind we're going to half this, so it's only going to be about 175 watts of power. That motor was more than that, so it could go up on the prop size. So this was drawing 35 amps. So obviously two speed controllers rated at 30 amps. They're not going to overheat, so I know there's not going to be a problem. I'm happy with the thrust. I'm going to test it before I start changing the props. And the reason it's sometimes better to go down in scale with props is because if you do go 4S, then you need to downsize the pitch of the prop or the length of the prop to compensate. And what you do is use this on 4S. So if I tested this on a 4S arrangement, then I could check the power and make sure I'm still not exceeding the wattage of the motor. I sound like I knew I was talking about that. You want to be cruising around at less than half throttle, and then if you want to give it some speed, then you go up over half throttle, but you don't want to have to fly around on full throttle. And on quadcopter motors, it was looking like you needed full throttle. You know, they were little 5-inch props. They're just not going anywhere, and that's the difference now. I'm gonna maiden it, get the power, get the thrust that I'm happy with. So if it flies and I'm comfortable with how it flies and I got the right power pack on it, then I can load it up. And when I load it up, it's gonna have the MyFlyDream and it's gonna monitor airspeed, it's gonna manage its own throttle, and then launch control. Throw it in the sky and off it goes. I haven't got to worry. I am going to ask somebody to launch my model for me. My other wings, the smaller stuff, no problem at all. I hold the wing, lob it up in the air and fly. Don't have any issues. But when I've got a big FPV model that weighs half a ton, I can't throw it like that, because by the time I get on the controls, it's gone thunk. Get somebody to throw it for you, right? You haven't got to be embarrassed. It's not, oh, real men throw their own. Yeah, that's great. Thank you once again for watching Team Woolly Sheep Reviews. If you haven't subscribed, then hit the subscribe button. Keep safe. Keep healthy, keep your distance, keep your hands off your face, don't touch your bits. We'll soon be through the other end of this blinking virus. So, take care, see you soon, subscribe, catch you soon. Bye!